Video lesson 9.3. So we're going to use SohCahToa to find the angle measures now. In the previous video we watched, we talked about how we can use the sine, cosine, and tangent relationships to find missing sides. But now we're going to utilize it kind of almost in an inverse process or backwards operation to discover how we can find angle measures if we know the actual side lengths. All right. So one important thing to know is the terminology. So when we're going kind of backwards here and trying to find the angles, we're going to use the inverse of the function. So we're going to use, well, the formal names are arc sine, arc cosine, and arc tangent. And I have them written down here. So arc sine, arc cosine, and arc tangent. They're just the inverses of the functions. If you just looked at your calculator real quick, just as a so it's easy to see, you have the sine, the cosine, the tangent buttons, right? But if you notice in the blue, you have sine with a little -1, cosine with a little -1, tangent with a little -1. Those are your arc functions, or your inverse functions. All right, so a lot more often, instead of writing arc, we just write it symbolically using the little -1 as an exponent. To get those, just simply hit second and type in whichever version you want. So second sine, second cosine, second tangent, would all be things. You would never embed them like this, but that's the idea. And what we need in there is to be able to put the relationship. So again, it all comes down to making sure you understand what angle you are referring to and the relationship that the sides have to that angle. So in this example, I'm referring to angle C. So with respect to angle C, this is opposite. Across from the 90-degree angle is your hypotenuse, which makes this the adjacent side. Now again, it's important to know that with respect to C, because if I said with respect to A here, right, this is no longer the adjacent side. With respect to A, remember this would be the opposite side. And the hypotenuse would still be across from the 90, so that's always the hypotenuse. And then with respect to the A, or the pink angle, this side now becomes the adjacent. So that's important. That's why it's really important to pay attention to which angle you are referring to, right? From here. So as you notice, angle C here, right? If we're dealing with sine, that's opposite over hypotenuse, right? So that would be AB over AC. That's what's written inside here. That's the relationship. Cosine would be adjacent, which is BC, over hypotenuse, which is AC, and that's what we have inside here. And last but not least, tangent, that's opposite, AB, over adjacent, which is BC, and again, that's what we have inside the parentheses here. So we're going to use those relationships, but we're just going to write it out using these inverse functions, the arc sine, the arc cosine, the arc tangent. All right. So from here, I'll show you how I like to kind of write this information out. This way we make sure we don't lose anything, we don't mess anything up. And again, we worry about, just like all the other times, we worry about the calculator at the end. Do all the work you can without the calculator, get everything in order and organized, and then the last thing you want to be doing is plugging it in and trying to figure out what your answer is from there. All right, so this first one. The other thing that's important to note is this symbol right here. This is called theta. So if you haven't seen it before, it's theta, T-H-E-T-A, right? That is just it's a Greek symbol, but it's a symbol that we use to represent an unknown angle. It's going to effectively just be a variable. Just think of it like it was an x, okay? But it is one that is very often commonly used, especially in trig, when dealing with angle measures. So it is something you're going to see next year when you're going to see it in next year in trig, or calculus or pre-calc, whatever that you may take in the future. That symbol is going to be there. So it is something you need to become familiar with. But for right now, since it's kind of like the introduction to new, if it's something that's bothering you, a little trick sometimes I say students off the side, just say let theta equal x, and then or whatever variable, and then move on from there if it really bothers you. But again, I think it makes sense to try to utilize it when you're doing your own work. But all right, so with respect to this angle, right, let's label all our sides. So across is opposite, across from the 90 is hypotenuse, and that would make this the adjacent side. So for this one here, I have opposite side, and I have the tangent side. So if I look back at SohCahToa, this tells me that I'm going to have to use tangent because I have the opposite and I have the adjacent. So here, so if I'm going to write sine of the angle, which we don't know, so I'm going to call it theta, is equal to opposite, which is 6, over adjacent, which is 7. Now in the past, we put this number over 1, we cross-multiplied, and we solved. The problem is, I don't have a number there. I can't type that into my calculator. I can't type in sine of theta and get a number, right? So putting this over 1 is not going to do anything for me. All right, so that's where we got to use our arc function. So once we set the relationship up, now we're just going to rewrite this. We're just going to rewrite it as the angle, so in this case theta, equals the function's inverse, so sine with a little -1, of, and we're going to put in parentheses whatever the fraction we have here, 6 over 7. Now that I've written it out in this format, now I can go into the calculator. Now we can take the calculator, hit second, sine, and put my fraction in. Again, if you have an updated model, you can use second y equals. That'll give you the fraction bar. Second, 6 over 7. All right. If not, just put it in as a division sign. Just make sure you close the parentheses. So here we've got, oops, we're not in, that's not correct because we're not in a degree mode here. So this should be in degrees. Let's redo that. So let's re-enter that function. That makes more sense. So now we've got theta is equal to, and what do we just get there? We got 50, what was it, 58? 58.9972. We are rounding to the nearest degree, so therefore theta is approximately 59 degrees. And that's my solution. All right, so that's the process. All right, again, it's the key, in my opinion, this is key. Setting up the relationship. To me, without that, then the rest, knowing what arc cosine, arc sine, arc tangent is, understanding what the inverses are, even being able to find them in the calculator, it means nothing if you don't know how to set up the relationship. So that's key, right? And it all comes out of SohCahToa. So that's why it's so important. All right, let's try another one. So again, with respect to theta, right, we've got opposite, we've got hypotenuse, and adjacent. So in this case here, I have adjacent side, and I have the hypotenuse side. So for this problem, with SohCahToa, adjacent and hypotenuse would give me cosine. So I'm going to take cosine of my angle, in this case theta, equals adjacent side, which is 3.6, over the hypotenuse side, which is 9.4. Again, when we're looking for the angle, we have nothing to type in the calculator here, right? So that means theta equals, we're going to use the inverse function of the fraction, 3.6 over 9.4. Now we can go to the calculator and plug that in. So in this case, we can type that into our calculator. That's going to give us a value of 67.48168. Again, we are rounding to the nearest degree in this case, so theta is approximately 67 degrees. Again, make sure your calculator is in degree mode. All right, last but not least, we've got this question here. It says find 90 minus theta. All right. Oh boy, what is that? 90 minus theta is just simply a fancy way of writing the complement. Right. All I want here is the complementary angle. All right. So this is theta. The complement would be the other one. Right. we know that the 90-degree angle, that's 90. That one's not changing, that's there. So whatever theta is, right, 90 minus theta would get me this one because all three angles have to add up to 180 degrees. So if I said, first angle plus second angle plus 90 has to equal 180, right? If I minus the 90 over, I'm going to have these other two equaling 90 as well. So these are complements of each other. So in this question, they're not asking us to actually find theta. They're asking us to find the other one, which in this case is angle G. All right, so for here. So I'm going to now do this with respect to angle G. So let me just do it in a different color here, make it a little bit easier to see. So now we're doing everything with respect to G. So this is now opposite. Across is hypotenuse, and that makes this adjacent. So here I have, with respect to G, I have the adjacent side, and I have the hypotenuse side. So that is using SohCahToa. I'm going to use cosine. So cosine of my angle. Now, I can't use theta because theta is over there. So if we use the just the name of the angle, so I'm going to use cosine of G, is going to equal adjacent side, which was 3, hypotenuse side, which is 4. So when I go to actually solve this one, right, I now need the inverse function of cosine. So G is going to equal the inverse of cosine of the fraction now that I have it in this form, I can plug it into the calculator. That's going to give me, in this case, was it 74.7424? And as we said, we will round this one to approximately 75 degrees. So angle G is equal to approximately 75 degrees. Now, if you wanted to, you could have found theta, right? We could have found theta and then plugged that in and said, well, angle G plus theta plus 90 equals 180. So I would have had something like this. I would have had like angle G plus the angle theta, or whatever the theta angle was, plus 90 all equals 180, right? And then you would have been able to find this value, right? And then look for G. You could have said, okay, add them up, subtract from 180, that gives me a value. But then you would have had to use the trig to find theta, then plug it in, and then solve for G, which is nothing's wrong with that, just extra work for yourself, right? If we just recognize that, well, instead of referring to it as theta's angle, let's do it with respect to angle G, aka its complement. Now I can just do the solving, and when I'm finished, that's my answer. So 2 different thought processes here on how you want to go about that. Both of them are fine. Like I said, I think that I did it this way because this way is a little faster, a little bit more straightforward in terms of solving, but you have to understand the relationships, right? If that bothers you, then by all means, just do what we did for A and B, find theta, right, for there, which would have been 15 degrees. And then you could say, do this, angle G plus 15 plus 90 equals 180. Combine these, right? That would be angle G plus 105 equals 180, minus it from both sides. Angle G would equal 75 degrees. So again, it would nothing wrong, but you would have had to do the trig and then do this additional work to find out the angle measure was the same. So like I said, I like to use the other one, but by all means, whichever version helps you. All right, so take the opportunity, pause the video, try these problems, look over the video again if anything's needs a little bit refresher or better understanding, and as always, utilize the practice problems for better understanding.